Before we start, you should get familiar with these terms because they're going to be crucial in the rest of our video. Once upon a time, there were two electrical engineers with the same goal. Jack Kilby and Robert Noyce both worked on the creation of the world's first integrated circuit, aka the microchip. This invention revolutionized the technology because it allowed technology to be much smaller and cheaper to produce. The first successful demonstration of the microchip was on September 12, 1958. In my lifetime, I managed to become an electrical engineer. My research allowed me to team up with my friend Mr. Noyce and create the chip. I managed to become a distinguished professor of electrical engineering at Texas A&M University, and I got a Nobel Prize in 2000 in physics for my integrated circuit. In my lifetime, I helped invent the chip. With Mr. Kilby, I managed to build my own company known as Intel. At Intel, I managed and oversaw the inventors who made the microprocessor. I was acknowledged by the IEEE for my contributions to the microelectronics industry. For letters A, B, C, and D, you'll be using Ohm's law equation to determine the missing values of the following circuits. In the next slide, I'll show you how to do that. For number A, you're going to use the equation V equals IR. So there's 6 for V, and for I it's 2 because the current's the same everywhere. So you can just get it from the top one and apply it to the bottom one. So you're going to divide by 2. So 6 divided by 2 equals R. And R equals 3. And the units for that is coulombs. So R equals 3 coulombs. For B, you need to know that the voltage drop in the external circuit equals the voltage boost from the battery. So basically what you put in, you're going to get out. So you're going to put in 6 volts, so you're going to get out 6 volts. And then you're going to put in 6 volts, so you're going to get the same in the amount for R, so you're going to get 6 coulombs. For C, you're going to need to use the equation V equals IR. You're going to try and solve for your V, so your I is going to equal 2A because the current's same everywhere. And then your R is going to equal 2. So you're going to do 2 times 2 is going to equal 4, so your volts are going to equal 4. For D, you're going to use the same equation. You're going to use V equals IR. V is going to equal, your I is going to equal 1, and your R is going to equal 2. So 2 times 1 equals 2. So you're going to have 2 volts.